and find the hypotenuse in all three of those triangles. Go. No, find the lengths of the hypotenuse, not which one is the hypotenuse. This isn't 7th grade math. Perhaps I should have been clearer. Find the lengths of the hypotenuse of each of these. They're all wrong. Although, if you think about it a little bit more, you've done something backwards. Do that without doing any calculation. Yes. Now, figure out what the other two angles are in that triangle.
Oh, wait.
The other two, the ones that aren't right angles. Yes.
I'm so confused.
How confused are you?
Is this wrong?
I'm still watching the
Yes, that's wrong.
No.
What did you get when you added 7 squared plus 7 squared?
98.
Okay, that's right. So somewhere your division, your simplification is wrong.
Oh.
You got a 48. I see.
Yeah. Okay, never mind. I feel like I did wrong, guys.
All right.
Yeah, they're right, guys.
So, in each of these triangles, by the way, what kind of a triangle is every single one of these triangles? Because it's got two congruent sides.
Isosceles.
It's isosceles. Each of these is an isosceles right triangle. So it's not just any ordinary right triangle, it's an isosceles right triangle. And we get that this is 5 square roots of 2, this is 7 square roots of 2, and this is 10 square roots of 2. Everybody good on that?
Oh my gosh.
Oh, okay.
Wait.
What?
It makes sense.
So, based on that, what do you think the length of the hypotenuse on this one will be?
6 square roots of 2.
6 square roots of 2. And it's an isosceles triangle, right? What does that mean about the two base angles?
They're
About 45.
They're congruent, and they're both how much? 45. So, in a isosceles right triangle, which is also called a 45-45-90 triangle, the hypotenuse is equal to the length of the leg times the square root of 2.
I think that saying 45, 90 triangle takes longer than isosceles.
Then isosceles right triangle?
Isosceles right. 45, 90. Yeah.
Wait a minute, it's isosceles right triangle, so you can't add triangle
Wait.
onto one and not the other
Okay,
one.
if we take all the
It
triangles-
is a few less syllables. Most people say 45-45-90
Why don't we just call them triangles?
because it's not just an ordinary triangle.
I think that you shouldn't be like giving these triangles an ego and telling them that they're extra special.
I didn't say they were extra special.
Not nice to the ordinary ones.
Sammy would know how it feels.
Ordinary ones should know that they're ordinary and then they're not special in any way, just like people.
I don't think that isosceles are extra specialer than normal ones.
Extra specialer.
Do you hear that?
They have their own name. Of course they're specialer.
But these are called triangles. They're special too.
Okay. So, in an isosceles right triangle, which you can also call a 45, 45, 90 triangle, it's your choice. The hypotenuse equals a leg times the square root of 2. So, if we were going to go the other way, a leg would be the hypotenuse divided by the square root of 2. This allows us to do problems like these incredibly quickly without having to do the whole Pythagorean theorem. So, for example, on number 1 here, if I was going to do the Pythagorean theorem, I would have to go, okay, since that's 45 and that's 90, this is 45, which would mean that this would be x. And if I was going to do Pythagorean theorem, I would have to do x squared plus x squared is equal to 12 square roots of 2 squared, which isn't horrible. You can do it, but why would you spend the time? All I have to do to find the length of the leg is take the hypotenuse and divide by the square root of 2. It's 12. That's all you have to do. Could you do the Pythagorean theorem on these? Absolutely. Is it a waste of time? Absolutely. All right, how about this next one? I've got the legs this time. How do I find the hypotenuse? Nope. I multiply by the square root of 2. So it'd be 8 times 2 is 16. Still much faster than doing the Pythagorean theorem. Yes, ma'am.
How do you just magically give a square root of 2 to multiply by?
Because that's the rule. There's no magic involved. Read the rule. What does it say?
An isosceles right triangle in an isosceles right triangle. The
We're going to be here all day.
equals a leg times
Which is the rule we figured out from the previous page. That the hypotenuse was equal to the leg times the square root of 2. So here, the hypotenuse will be 11 square roots of 3 times the square root of 2. That's 11 square roots of 6.
So really, we're not doing anything with the 45 degrees. It's just there to tell us it's an isosceles.
The 45 tells you that it's an isosceles right triangle.
Why do you not need them in 2 and 4?
Because we knew that these two were congruent. So that tells us it's an isosceles right triangle.
Oh, yeah.
So on this one, what do I need to do to the hypotenuse to get the leg? Divide by square root of 2. This is why we did that on the Friday before the break, how we simplify square roots when we're dividing. That's 18 square roots of 2 divided by 2, which is 9 square roots of 2. Same idea on this one. The leg is the hypotenuse divided by the square root of 2 in a 45, 45, 90 triangle. I can't do the division, so I'm going to multiply by the square root of 2 over the square root of 2 to rationalize the denominator. That is, get rid of the square root on the denominator. And it's 23 square roots of 2 over 2, and we will simply leave it like that because 2 doesn't divide into 23 evenly. That's 45, 45, 90 triangles. There is another special right triangle that we're going to look at in just a second. So let's look at this. If an altitude is drawn in an equilateral triangle, an altitude is the height from the vertex perpendicular to the opposite side. Two congruent right triangles are formed. Well, let's verify that. Are these two triangles going to be congruent if you take an isosceles triangle and whoosh, draw that right down the middle?
Yeah.
Yes. All right. What is that going to do to this 18 down here at the bottom? Split it. Both of these are 9. I can do the Pythagorean theorem to find y. Let's see, that would be 9 squared plus y squared is 18 squared. Oh, you know what? I don't want to do that. This is 9 times 2, right? And 9 times 1, so this is going to be 9 times something. 1 squared plus b squared equals 2 squared. That'll be 1 plus b squared is 4. B squared is 3. So b is the square root of 3. Oh, this is 9 square roots of 3.
If we would have just solved it normally, we'll just stuff it on the other.
Oh yeah, it just takes longer. How about this one? Well, when we draw in this altitude, it's going to split the 20 in half, so both of these are 10. What do you guess that y is going to be?
10 squares of 1.
What?
Wait. 2 times something.
Here it was this times
It's
square root
10
of,
times 120. I mean, wait. The bottom is, shoot, it's like 10 times 1. The 20 is 10 times 2. That's going to be 10 times something.
right, 10 times what?
10 times square root of 5.
Why are you adding?
Oh.
That was very aggressive.
Would it be 10 square roots of 3?
Yes, it would be 10 square roots of 3,
Go Aries. Oh.
because that's the hypotenuse.
Yeah, I was.
You were adding.
Wait, I'm confused.
So this would be 10 times 2, and this is 10 times 1, so this is going to be 10 times something.
1, 2, 3.
No, because it's 1 squared plus b squared equals 2 squared, exactly like it was over here. So b is going to be the square root of 3. So that's 10 square roots of 3. Every single time you take an equilateral triangle and drop in an altitude, that's going to happen. So don't worry about writing it down, but if we do this, if this is an equilateral triangle and every one of these sides is 24, how long is this going to be?
12.
12. And this?
12.
And this?
12.
12 square root of 3.
12 square roots of 3. Every single time. That's the pattern. Yes,
How did you get the square root of 3?
I showed it twice.
Yeah.
I'm not going over it again.
Okay.
All right, so in an equilateral triangle, what's the measure of every angle?
The same.
Yeah, and what is the measure of every angle? It's 60. And if this original angle was 60, and the altitude splits it in
30.
30,
Savannah.
60 to that.
Wow.
these two little triangles are called 30, 60, 90 triangles because those are the angle measures. The shorter of the two legs is half the hypotenuse, and the longer of the two legs is the short leg times the square root of 3.
Can you say that again?
Yeah, the shorter of the two legs is half the hypotenuse. 10 is half of 20, right? And the longer of the two legs is equal to the short leg times the square root of 3. Okay? That's the rule for 30, 60, 90 triangles. In a 30, 60, 90 triangle, the short leg is half of the hypotenuse, which means the hypotenuse is twice the short leg, same thing, and the long leg is the short leg times the square root of 3, which would mean the short leg is the long leg divided by the square root of 3. So let's do these problems. The simplest kind is the one like you have here, where you're given the short leg. Because the short leg is half the hypotenuse, so what did the hypotenuse have to be? 14. And the longer leg is the short leg times the square root of 3.
7 square root of 3.
Exactly. Now, before we go on, how do we know that this was the shorter leg and this was the longer leg? And please don't tell me it's because it looks like it.
Because it has the
Angle measure.
What about it?
it's really just 60 degrees.
Yeah, and this is across from a 30. The shortest side of a triangle is across from or opposite the smallest angle.
Oh, yeah.
So this must have been the shortest side. This has got to be the longer leg then. This one's almost as easy when you get the hypotenuse. Yes?
Is y 6 and x is 6 squared is 3.
Perfect.
This isn't actually that hard.
It's really not. Now, are some of them a little harder to work out? Yes. Let's do some that require a little more work on our part. So which side do I have this time?
The longer leg.
Yeah, I've got the longer leg. So to get the shorter leg, what do I need to do? No, it's half the hypotenuse, not half the longer leg.
8 square root 18. Oh, wait.
Square root by
Square. Not
times
square.
by the square root of 3.
No,
Divided by square root.
divide by the square root of 3.
I was close.
The long leg is equal to the short leg times the square root of 3. So the short leg will be the long leg divided by the square root of 3. So this will be 18 divided by the square root of 3. Remember how to work that out?
Times the square root of 3. On both sides.
On both sides.
Denominator and
Numerator. Yeah. Multiply by the square root of 3 over the square root of 3. So it's 18 square roots of 3 over 3. Simplifies to
6 square root of 3.
6 square roots of 3.
Will it always be the number, like the long, if we're doing this to find the short side, will it always, yeah, to find the short side,
The short leg.
short leg, it would be a third of the long leg and the square root of 3.
Times the square root of 3? Yes, but the problem is what if it's not divisible by 3? That's why I don't memorize the rule that way, but it's true. And then how would we get the hypotenuse?
Double 18. I mean, 18 plus I don't know.
Oh, 6 square root of 3 times 2.
Yeah, which is?
12 square root.
Right. The hypotenuse is double the short leg. Okay?
So,
Yes?
does the short leg always have to be long the square root of 3? Or can it be the long leg too?
Yeah, the square root of 3 could be anywhere.
So it just needs to be one of the legs.
I don't know what you want me to say. It's possible that none of them have a square root of 3 in them.
Okay.
Okay? But the relationship holds no matter what. The short leg is half the hypotenuse, and the long leg is the short leg times the square root of 3. All right, so for this one, the hypotenuse is 15. Now, we try never to mix decimals with square roots. Some of your eyes are glazed over here. So instead of writing that as 7.5, I'm going to make it 15 over 2 and just leave it. That's the short leg. If you don't have the short leg, find it. It's always the first thing to do. Find the short leg. Then from the short leg to the long leg, what do I do?
Multiply by the square root of 3.
Multiply by the square root of 3. Exactly right. So that's going to be 15 square roots of 3 over 2. This next one is about as ugly as it gets. Which side do I have in this case? The long leg. So I want to find the short leg. Short leg is the most important piece. It's involved in every one of the calculations. So, what do I do to the long leg to get the short leg?
Divided by square root of 3.
Exactly right. Divide by the square root of 3. So then I'll rationalize. That's multiplying by the square root of 3 over the square root of 3. So this is the truly spectacularly horrible 11 square roots of 3 over 3. That's not really all that bad. Then what do I do to the short leg to get the hypotenuse?
You multiply 2.
Yep, multiply by 2, and that would be what?
22
Over 3. I'm not multiplying by 2 over 2. I'm just multiplying by 2,
So
which
when
is
you-
2 over 1.
So you don't multiply the 2 times the square root of 3. Oh, no, you don't.
All right, on this one, which side do I have?
The short leg.
The short leg, so I can find anything I want. Turns out I need to find both. So let's find the hypotenuse first,
4 square root of 3 times 2.
which is?
8
8 square root of 3.
Right. And then what do I do to find the long leg? Nope.
Multiply by the square root of 3.
Multiply. If I'm going from short to long, I want to multiply.
Okay.
So 4 square roots of 3 times the square root of 3. What's the square root of 3 times the square root of 3?
3.
3. It's 12.
This is so easy.
Yeah, it does take a little while to memorize it and get the hang of it. But yeah, once you do, you can just zip through these.
On the last quiz, we did this too.
I don't